Cha. Okay, today's actually pretty easy. Ooh, we gotta talk about even and odd. That's a good deal. We'll talk about that. Okay, here we go. Let's start here. We're gonna start with our parent functions because it's transformation of parent functions. Should we just go to the heart of the hearts? You guys want to go to the heart of hearts? What's our parent functions? First off, have we done parent functions already? Did I show you the main ones? We had f of x equals x squared, right? We did the table. Didn't we do this? We did. Okay. Well, we're doing them again, I guess. Because it says to. That's a good reason, huh? And then you just plot those points 0, 0, 1, 1, 2, 4. Should have the shape of a parabola, right? Whee! Let's see. Let's look in the homework to see which ones they have. So, looks like they have square roots, absolute values. Squared, fourth root. Let's do a fourth root really quick just to make sure. What would be nice fourth roots? We want to have perfect fourth roots. So 0 is the first best one, right? 0. How about the next one? 1. And then 16 gives you 2. So it's like, it looks like a square root, but it's just longer. It's like steeper. 8, 9, 10, 11, 12, 13, 14, 15, 16. And notice it's like a parabola being stretched, right, to the fourth power. Everybody good there? Any questions? Ready to rock? Yeah, man, we are ready to kick A. Thanks. I apologize. No, I don't think I could. Shiloh, I'm really sorry you got sickened. Did you huck a lung? Yeah? Did you get some phlegm going? You know what the best thing to get my phlegm out? Just sitting in the no. Oh. Just sit in the shower and just let that sucker hit your back. And I cough up, like I cough a lot, but I cough up the most stuff in the morning, and it's so awesome. I'd probably sit there just for 5 minutes hawking a lung to get all that stuff out because it like loosens it up. And Mucinex, I don't know how that works. I've never used it, but anyway, are we good? That was your fault, by the way. We're talking about phlegm, not yours first. Because I wouldn't have got on there if we didn't wait. Hey, so which schools did you go look at? Just U of U? Oh. Oh. Nice. Okay, okay. I like it. I like it. We're done going to start right here. I say what? I say. Boy? I say. I don't know what my favorite movie. Probably Saving Private Ryan. Oh, every time it's on TV, I watch it. I actually have it saved on my DVR just so I can watch it anytime. Yeah, it's so weird you guys don't have satellite and stuff. You guys all have that weird shiz. Netflix, which is the worst. That's right, you do. Your parents do, but you're just you don't pay the $150 a month because I do. It's well worth it. $5 a day. I mean, 5 hours a day times it by that's like $1 an hour. Perfect entertainment. Okay, who's our nice square roots? 4 is a good one. 1's a good one. I like 0, right? I know, right? Okay, next thing we're going to do, ladies and gentlemen, on the negative on the inside, always work inside out of your function, right? So what does that do, ladies and gentlemen? Anybody remember? The x is by a -1. Okay, let's actually change this if that's okay. I want to change it just a little bit. So don't. Did you start going? No. All right. Well, you can change it because you have nice notes. So let's say we had -1/2 x. Let's make it the hard. Okay. Does anybody know what I do to the x's on this one? I multiply it by -2. On anything on the inside, like if we see timesing by a half, we divide by a half, but dividing by a half is the same thing as timesing by 2. Yeah, or yeah, doesn't necessarily, but like think about this. Okay, if I want 4 to be, because that's a perfect square root, what number am I going to have to use? So like -8 would, because -8 times -1/2 gets me back to 4. So we're saying, what would it get me back to 4? Well, I'd have to double the number if I'm cutting it in half, right? So this would still be 0, -2, -8, -18, 0, 1, 2, 3. Once again, if you don't believe me, what can we do? At any stage, plug it in. Let's try -18. -18 times -1/2. 9. Square root of 9 is 3. So do you see how it still works? Yes. Well, yes. Understand the negative is going to be there no matter what, right? Yeah. But it's the reciprocal of what value. So if there was a 3 there, I'd times all the values by a third. If it was 100 there, I'd times everything by 100th. 1 over 100. Okay? Inside, yep. Okay, the next thing after that is the multiplying by -3. Because I could also put this, that +2, I could put it in the back side. Does that make sense? Zero, -2. The x values aren't changing, are they? The y's on this. So what do we get here? 0, -3, -6, -9. And then our last step is, they have it out front, but it's the same thing as putting that +2 back here. Would you guys agree with that? How's debate going? You liking it? Yeah, just something to do with Mr. Morris. Which one are you in? What is that? I don't know what that means. It's intense. Are you with the Asian girl? Who's that girl? And she works policy. She works with Mr. Yeah, that's what I heard. And it's consistent the whole year from what Mr. Benight said. Okay, guys, so that's what it is. Not too hard. We can do this stuff, right? Okay, so the next thing, though, is all graphs. Like, once again, what about a piecewise? It's still a function. Would you guys agree? Okay, let's say I drew this for you. Bear with me. That should be like a parabola. Okay, so this is like just a generic one. It's a couple of parent functions put together as a piecewise, right? But it's still a function because it's passing the vertical line test, right? So we'll call this guy f of x. Okay, so we're going to do a t-chart of f of x. So who's a nice point? Well, that's a nice point. You guys agree that's a nice point, that's a nice point, that's a nice point, that's a nice point, and that's a nice point. Agreed? So let's put those points down the xy chart of f of x. Is everybody with me on that? Yep. So this is negative 4, 0, negative 2, 2, 0, 0, 1, 1, 2, 4. Does everybody understand where I got those values from? They're just very distinct points on my graph. Hey, how's the dance seem like it's coming? Like, people, I hear a little bit of yes and no's. Huh? No, the preference one. Oh my, there's so much of that bull crappies. It was, because, yeah. But I asked a lot of girls in my one class, and they kept saying, I was like, are you guys kidding? I said, I'll give you extra credit. Didn't happen. Anyway, so let's say, guys, I have you do this. Who you taking? Maybe. Gotta do the math dance. I'm just giving it to you. Here, I'll put below. Given. How's that? It's actually coming up. Nope. Nope. This is like doing the same thing. So notice, just like on this problem right here for you, is I gave you this, right? Yeah. Didn't we start with our parent and then start adjusting it? So this time, because it's not your non-typical, I had to give you its parent, right? And then now, what does this do? We're going to take my parent function, and what are we going to do to it? Shift it right one, huh? Does that make sense what I'm saying? Does everybody understand that? This is just any random function, and I'm still can do the same thing. It doesn't matter who our parent function is. We just have to do the same movements. Yeah. Just like we did on the other one, right? Yeah. So then this would be negative 3, negative 1, 1, 2, 3. Agreed? See how I moved everything to the right one? Does that change the x, the y values? No. Okay, then what do we do? If you'll take everything out of that bottom drawer, bottom left, and put it in the recycling, and then put everything in there. So then we do the 3, right? So that's the y values. Okay. So that's 0, 6, 0, 3, 12. Right? The next one. Did you at least get my email, Shiloh? I sent it back, right? I didn't dog you. You could do the +1. I'm just making sure. I got to remember that kids aren't here. Yeah. And that's what I'm using this for, just to make sure. Way to go, Lenhart. You have class today? You have class today? Every other week? Oh, because it's on Tuesday, Thursday, or something like that. Which today's Tuesday, Thursday, so it's a Monday, Wednesday, Friday class. Okay, and then that's the graph, so that's the one that we're going to plot, right?
So then we'll plot him, and it should still have that same graph look, right? Just stretched, moved, and so forth. Would you guys agree? Okay. I know. I'm guessing senioritis is hitting you pretty hard. Yeah. Why? What have you had today? Who teaches honors art? Oh, that's horrible. That last part was bad. There we go, the graph. I like Miss Benson. She's had a seizure the other day or something. Hope she's doing well. She bled a lot from what I've been told. Like she hit her head on the concrete and they came out and it was 13 it should be. Because it's 313, right? Does it have the same graph just stretched, shifted?
I don't care as long as you know what it is.
Yeah. You did? That's scary. I remember a girl having night seizures in my class. I'm like, I don't know what the hell to do. Like, I wanted to hold her, and they're like, don't touch her. You just got to make sure they're safe. And I just, like, she was hitting her head on this kind of floor, and I'm like, okay, so I just at least put, like, I had a blanket. I put a blanket underneath there, and it's just so she didn't. The funny thing was that girl was about to take her road test in 5 minutes. Yeah. Yeah. Are we ready to go? We good? How was that? We guys did good with that? Okay, so let's say I give you the parent function of an absolute value. Okay, so I start you off with a parent function. And here's what it tells you. It says it goes shifts right 3, reflects about the x-axis, vertical shrink of a half, and then up 6. So then I want you guys, knowing that information, to build the equation. Nope, just build it. Okay, so who's on the inside of the absolute value? The shift. So we have just this shift right here. This shift right here is the only one that's about on the inside because it's the only one that moves it right or left. If it says reflects about the y-axis, that's like this becoming this. Or if you had like this, if I reflect it, then I come turn around, right? So here's this. If I reflect about the y-axis, there's that. Same graph, just notice how it was over there that time, comes over here. Does that make sense? Did you see that over there, Liz? Okay. So this would be right 3. What do we do for right 3? -3, okay? But because it's reflection about the x-axis, that's on the outside. That made me go from this to this. So it's a negative out here. And what's it going to be? 1/2. And then up 6 plus 6. So that's what that is. It's law enforcement, I think. He's probably showing them, like, there's a person that talked about not having guns and how a police officer, how they were mocking a police officer. about how the situation happened, and he's like, well, you didn't look at all the situations, and they put those same people in situations with like I don't know what they had, but they had a cap gun or something like that, and or a paintball gun or something, right? And then they put them into situations that in the past people have or have not shot the person, just to give them a more realistic time frame of sometimes how much decision time they had. And it was pretty interesting. And those people, like, I need to shut my mouth, because it was just, I'm not saying it's not always that case, but there's split seconds that you have no idea, or this and that. I don't know. I just want everybody just to, if they tell you get your butt on the ground, get to the ground. If they put your hands up, get up. If they tell you to drop the sword, did you guys ever remember the guy that got shot at freaking Panda down in Saratoga? Yeah, it was like 6 years ago. But there was a guy with this big samurai sword, and they told him to stop, and they kept coming after it. He kept coming walking, and he had a sword, a samurai sword. And he kept walking towards him, like, stop, stop. And then, they could have shot him because he's still walking, but they didn't. Then he turned around and started walking toward Panda. So who's to say what's happening there? And they shot him in the back. And anyway, he just kept doing stuff that they told him not to, and so then this family's like, and I'm like, it's just a hard thing to do, and who's to say really who's right? And you get what I'm saying. It's just, sometimes it's just not fair to either party sometimes, Okay, really quick, we're going to talk about even. Huh? I could be older, but we could look it up. But my friend, he's Asian, and he's like, they had no right to shoot him. I'm like, dude, the whole thing is they're not listening to orders. Now, granted, could there be some times about like they're deaf? Like I had a student that was deaf, and maybe he couldn't hear, but if you can tell if somebody's yelling at you to do something and they're a police officer, you're going to stop doing something. I'd be like, if I couldn't hear, I'd be like, I'm down on the ground. Here I am. There it is. Just, they're looking. Yeah, he was walking towards them, and they were giving him instructions, and then he turned about faced and started walking to the door, like he was almost to the door. Who's to say crazy people nowadays, right? Anyway, so even or odd functions. I think we did this in the 1010, didn't we? I think we did. And if you don't remember, it's okay. It's when, remember, we have our function, just our regular f of x. Oops. We have just our regular f of x. And remember, the thing that you do is you replace f of x with negative x. And if it comes directly out as the same function, it's called an even function. So you start with your function, you replace the x with negative x, and if it comes directly back to the same function, it would be an even function. Anybody have an idea of what that would look like? Hey, Matt. What one is it? Here's an example, guys, of an even function. You'll see one of those coming up. Here's an even function, guys. No, you're good. Why? Because... Well, it's because you're gone half the damn semester. So you take the function, and then you replace the x's with negative x's. That's how you're always going to tell if it's even or odd. Replace the x's with negative x's. Can somebody tell me what I get when I do negative x squared? What do I get? X squared, right? What do I get when I get negative x to the fourth? You see how I got the exact same equation back after I replaced it with x? Make sense? That's an even function. An absolute graph. like just the absolute value of x, is an even function. What about absolute value of x minus 1? No. Another rule to see is it look at the graph. If you look at their graph and it's symmetric, my hand's starting to hurt, so I'm not going to do that, about the y-axis. So then you know it's even. So absolute value is a v, right? But as soon as I shift it to the right one, is it now symmetric about the y-axis? No, because the vertex isn't lying on the y-axis anymore. Just like a parabola is symmetric about the y-axis, right? But as soon as I shift it to the left or to the right, it's no longer symmetric about the y-axis. Exactly. Or we haven't really got to rationals, but like if I had 1 over x squared, that is 1. Because here's what its graph looks like. Bear with me, it's not perfect, but you get the idea. Is that symmetric about the y-axis? If I fold it, it would land right on top of each other. Yeah. Does that make sense to everybody? Kath? Good. So an odd function. Okay, so this is odd functions. If I take my function, do the same thing, I replace it with f of negative x. So you do the same procedure. Does that make sense to everybody? And you get the direct opposite, so f of negative x. See how it's the opposite of that function? That's what that negative means. So you take your function, put the negative x in, and you get negative of your original. So let me give you for example. So if I had f of x equals 3x cubed. Okay, so then I start with replacing the x was with negative x. And notice we get negative 3x cubed. And notice that's direct opposite of what we had, right? It's the direct opposite. So that's odd. And on the graph, if you're looking at a graph from the odd perspective, it is symmetric about the origin. You guys know what that means? So basically it says this. If I have point xy, the point that will be on my graph will be negative x, negative y. That's what symmetrical about the origin is. So, for example, x cubed is an odd function. And it's not just because it's x cubed, I mean, that does help. But let me give you, for instance, let me put some points on this. Notice we had this point to be 0, 0, right? Another point was 1, 1. Another point was 2, 8. Agreed? Is everybody there? Okay, but we also know another point on this is negative 1, negative 1. And notice that's direct opposite of both points. That's odd. So another one would be, hence, negative 2, negative 8, because they're direct opposites of what they have. Okay. Now, let me ask you guys this question, though. Y equals 4x minus x squared. So that's a parabola, right? What does a parabola tendency look like? Have a tendency to look like a parabola, and it's usually symmetric about the y-axis, right? But if I went ahead and check this, I should have not y, I should have f of x. I apologize about that. So, once again, let's check. So I'd get 4 times negative x minus negative x squared. I get negative 4x minus x squared. Y is, remember, just a different name for the output of a function, right? Okay, so now notice on this, guys, was it exactly it? Is it exact the same as this guy? Is it its direct opposite? So it's not the exact same, and it's not its direct opposite. So this is a neither. So it's neither odd or even. It doesn't have to be odd or even. It can be neither as well. Okay? Why are you giggling? Hey, that was bad. What else should I? What number? At least I don't start a 0 from the down bottom. I mean, look at that shit. Come on. I've seen kids write 2s this way. I'm like, who does that? Anybody write from the bottom? You do, don't you? How do you write from the bottom? Start from the top, come across and over. So I go. So you're a snowman? Are you a snowman? Huh? You this? That's so weird. Shush. Okay. So now, guys, let's say I give you a graph. Let's say I give you this point. I'm going to give you some points here, some context. Let's say this point's at 2, 4. And this point right here is at 4, 0. What would this graph look like if it was an even function? Like, what would be the other half? Because right now I only have half of my graph up. If it was even, what would it look like? No. Reflects about the y, so where would this point be? Negative 2, 4. And the other point would be negative 4, 0. So it'd come up like this. Yeah. Uh-huh. Okay, let's do the same thing, but this time let's do it with an odd graph. Okay, it's a lot harder up here. Okay, odd graph. What would it be? So it would go over and down, right? So it'd be negative 2, negative 4. Does that make sense to everybody? And then it'd be negative 4, 0. So we'd go like such. Then we come down, don't we? Does that make sense how that works, though? Basically, odd, keep the same x, opposite x, same y. On an, oh, shiz, that wasn't even. Let's say it again. Even, opposite x, same y. Odd, opposite x and opposite y. For an odd, it's opposite x and opposite y. So like here, remember the points, if I give you the point x, y, an odd point would be negative x, negative y, right? That makes sense, Junior. But if I was an even, if I gave you x comma y, you would do negative x comma y would be the point. Make sense? I think that's it, guys. Yeah. Okay, so here we go. So you're on 2-6. Hold on, let me push pause for a minute. Okay, so we're going to go number 11, 15. I'm actually thinking about this really a lot, so you don't have just trash. Sometimes they give you trash, I'll be honest. I do. Sometimes it's really when I'm rushed. Yeah, that's right. No. You can go leave and I can mark you absent. Why? What would you go do? You have friends? Sorry, mate. Denny's, you said? They're juniors and they didn't stay. They're dingleberries. They're dingleberries. Like, that's a good, today's a good day. I'll be honest. Like, you should really take advantage of what really it is. Like, it's a good day to get in there, ask questions. But whatever. Thank you. What are you doing? Okay. That's it, guys.